Okay, the next cipher is called a multiplicative cipher. The method is, instead of adding the key to the position of plain text, we multiply the key to the position of the key. Of the text. So the method is like this: if P and C's are the plain and ciphertext is each other, and key is K, then ciphertext is congruent to K times P modular 26. And for deciphering for that ciphertext, all you need is just multiplying K inverse for modular 26 on both sides. Then we got P is congruent to K inverse C. One problem here is that every number K has its inverse for modulo 26, because 26 is not a prime, so there are only few numbers have its own inverse, and there is a kind of formula and a name for that, right? So one possible question here is how many keys are possible for this multiplicative cipher, okay, in English alphabet. Okay, please thinking about it. Anyways, one counter example for such case is if K is 4, then the letter A, the number for number A is 1 or 0, well, it depends on how you define it, and multiply by 4, it changed to 4. So maybe it changed to A, B, C, D, or D or something like that, right? That's for the ciphertext. But for letter N, the assigned number is 14. Then if you multiply 4 there, then it's changed to 56, which is congruent to 4 modulo 26. So if you have A and N in your plain text, both of them to assign to number 4, which is D. So when you change back to original plain text from ciphertext, you're not going to get A or N. You might get just A or N for both. So you're not going to get original plain text. This is only one case, so there might be there are some other letters like having same properties. So you're not going to get really nice plain text back. Okay? So that's the problem. So there are some restrictions to choose for the key in this multiplicative cipher.